I wanted to begin by introducing myself because I came to India really hoping to meet people and start some collaborations. So this is going to mostly be a talk on kind of social impact work that I've done, and I'll say more about that in a minute. But I wanted to say just a little bit about what my kind of research focus has been in case we have other points of contact that would lead to interesting conversations today. So most of my work is on game theory and market design, thinking about how to construct novel, mostly auction markets. I've done some work thinking about behavioral game theory, trying to formalize models of how humans make strategic choices in sort of game theoretic settings. And also I've done some work on computational game theory, trying to think about how to computationally solve game theoretic questions like finding Nash equilibria, correlated Nash equilibria, problems like that. And as Danish mentioned, I've got a Coursera course on game theory that is a good entry point if game theory is something that you've always wanted to learn about but haven't. My other kind of major area of research focus is heuristic algorithm design. So I like to think about algorithm configuration and algorithm portfolios. And broadly, the way I think about that is that you probably heard about work on heuristic algorithms where people say, I've got a SAT formula or like a mixed integer programming problem, and I'd like to solve it as quickly as possible. I know it's NP complete in the worst case, and I'm not a crazy person, so I think probably P is not equal to NP. But nevertheless, I've got some bunch of ideas about how I might exploit structure in this particular problem. And I can do really well on average. And there's this whole kind of industry of people making up new heuristics that they claim will work well. And the perspective that I have is that you can really think of heuristics as being like a machine learning problem in a formal sense. So you can think of the space of heuristics that you might employ as being a space of different parameter settings, just like a kind of design space for a machine learning problem. You have some data on which you want to achieve good loss, and finding a good set of heuristics for some problem is really like fitting a model in machine learning, where you want to find some well-performing space in your hypothesis space, and you want to achieve good loss. You want to make sure that you generalize from your training data to new data that you might face, and broadly, this is what I would call algorithm configuration. And is that it for my mic? I think it just stopped working. It might not have much battery power. Yeah, it looks like we are very low on battery power here. Do we need to switch it, or? I think it's just going to die again. I'll go to this microphone while we wait. Is this working? Okay. This will stop me from roaming free, but yeah, anyway, so I'll be giving a talk about that at Google Research tomorrow. If any of you feel like spending 45 minutes in traffic fighting through the streets of Bangalore. And I also do a little bit of work on large language models, mostly through a startup company in Israel that I'm involved in called AI21 that has done a lot of kind of research in mostly how to augment large language models with retrieval and with other kinds of tools. And more recently, I've been thinking a little bit about what would it look like to build large language models that can behave as economic agents? To what extent can we trust them? How would we know whether we can trust them? So that's also something I'm interested in chatting about if that's an interest of yours. And finally, I've thought a lot about how can we do kind of socially impactful work leveraging AI. And here I've thought a bunch about how we can apply AI in education. So I've thought about building peer review systems that leverage Bayesian inference and other kinds of AI techniques to, there we go, free once again, all right. Yeah, so I've thought about building peer grading techniques leveraging AI. I've thought a bit about how to encourage class participation through technology, and also applied AI techniques to the operation of AI conferences, such as AAAI. So we published a bit on how to how to break up collusion rings, how to do a better job of matching papers and reviewers together. I've applied auction design and heuristic algorithms both to the design of government spectrum auctions. And I've also done some work in agriculture, which I'll tell you about today. So that's enough about kind of the big picture of me, but this is all just in case any of you feel like chatting about something that wasn't in the talk. Let me now tell you about the talk that I'm actually going to give today. So this talk was aimed for an audience, I think, quite different from the people in this room. It was originally a keynote talk at an AI for Social Impact workshop at AAAI. And it was aimed at mainly North American and European researchers who wanted to do socially beneficial research. So Danish and I were chatting last night about why he thought this talk was interesting for this audience. And so I added this slide to try to contextualize this because let me preface kind of everything I say today by saying I don't know what I'm talking about. I don't understand the Indian context. I'm here because I want to learn about your perspective and about more broadly how computer science research can be of benefit in India. But my impression is that the typical kind of IISc or IIT researcher prioritizes theory and method over kind of applied research, and so. My impression is that it may not be entirely obvious to all of you, or at least to this is maybe a selection effect that you're the ones who chose to come to this talk, but it may not be entirely obvious to sort of the broader faculty that you're part of that AI for social impact work is a really hot area that a lot of people at sort of top universities around the world are very excited about doing. There really is a lot of students who come to me who'd love to do this kind of work. There are other more junior colleagues who come to me and say, how can I get involved in this kind of research? And the kind of dirty secret of this research area is that there's very little research that succeeds at doing what it wants to do, of actually combining computer science research with socially impactful outcomes in addressing underserved populations. And this talk is really kind of a reflection on why that is. So I haven't done fantastic work in this space, but the space is kind of struggles so much that other people look to me to ask why I've been even as moderately successful in this space as I have been. And this talk is kind of a reflection on what we've done that has both succeeded and not succeeded, from the perspective of trying to think about how we can all do better. And one of the themes really is that I think it's pretty doomed if you're some white guy living in British Columbia who wants to have an impact, in a country that is not Canada, to just sort of sit in British Columbia and read a couple of papers about, what life is like in Uganda or India or Cambodia or, whatever country it is, and come up with some solution and try to deploy it. I think that's a pretty colonialist attitude, and it's very unlikely to succeed. So one of the themes of this talk is that collaborations with kind of stakeholders in the communities to be impacted are just absolutely fundamental if any kind of useful solution is to be achieved. And I think that makes the people in this room really well positioned if you're interested in doing this kind of work, because kind of just down the street are the kinds of stakeholders that you might want to collaborate with. And so I think many researchers around the world, including me, are really eager to find collaborators who understand computer science and can bridge to domain experts in the kind of receptor communities of interest. And so that's one reason why I've come here. I'm really interested in establishing those kinds of collaborations. But definitely, it's not just me. There really is a large community around the world of idealistic, smart graduate students and assistant professors who want to go out there and start these projects and just don't know where to begin. So that's been me talking for a while. I'm not exactly sure what the talk culture is here, but I heard a rumor that you guys like to interrupt and ask questions and offer opinions. And if that's true, I encourage you to go for it. So now or at any time, if you've got something to say, don't wait until the end of the talk. This will be more fun if I hear from you throughout. Okay, so let me say one more preamble thing before I dive into the the two projects that I've got a tale of here. So as I kind of said on the first slide, one of my key kind of methodological hammers is market design. So let me say a little bit about market design, what it is, what it's for. So markets are really a way of allocating scarce resources in settings where you've got a bunch of different agents or people who are self-interested. Self-interested doesn't mean you don't care about anybody else. It just means that you have your own interests. You have your own sense of what it is that you're trying to achieve in the world. And information about what everybody is trying to achieve is not available centrally. So people might lie to you about what their interests are. They might, they're going to not necessarily act in the market in a way that follows instructions that they're given from authorities on high, but instead they're going to do whatever they think is in their own interests. And the designer cares about some kind of good social outcomes. So the designer is interested in making something happen that makes some sense from a kind of global perspective. And as Siddharth here knows, computer science and AI have had quite a big impact on market design in the last kind of 20 years. This is now a really rich area in computer science, mostly because of the rise of the internet and the fact that electronic markets are kind of a thing today. But as markets have become electronic, it becomes easier for people to express preferences in a rich way. You start to be able to say not just, I'd like a cab, but I'd like a cab right now that starts in this place and goes to that place. And this means that you can then clearing a market, trying to decide who should I match up with you, becomes a hard computational problem. If you think about what's going on behind the scenes in Uber or in any other kind of electronic market, you're solving a complicated routing problem, and you're thinking of, this cab is going to end up, start in one place and end up in another place, and who am I going to match it with later, and what would I have to pay the driver to make them want to do this thing? So generally, kind of electronic markets lead to computationally complex clearing problems. So that's not kind of the only sort of social impact problems I'm interested in, but I think the design of smarter market problems for solving allocation problems are a pretty good sweet spot for a place where where socially beneficial outcomes can be achieved, and that's what this talk is going to be about. So the first problem with 4 collaborators here, Taylor Lundy, Alex Wei, Hu Fu, and Scott Commoners, is actually not a problem in the developing world, but this is a problem in Canada and the United States. So this is thinking about the problem of allocating donated food. So in the United States, food banks are large centralized organizations that receive donations of food, which must then be redistributed to local subsidiaries of this large organization that are called food pantries. And the food typically spoils, so it has to be sent to these food pantries before knowing exactly what the demand is going to be. And to do this in a sensible way, the food bank needs to ask the food pantries to report their demand. And all of these things are charities. They're not selling the food. They're not trying to kind of make money off of it. But inevitably, the food pantries are a little bit more concerned with meeting the needs of their own communities than they are with the kind of global picture. And so they have an incentive to over-report the demand that they're going to experience because they don't want to run out of food. And the standard kind of economic approach to this kind of over-reporting demand kind of setup would be to introduce payments, to say, we're going to sell you the food. This is going to give you a reason to not over-report because you're going to have to pay us. And this just doesn't work in the food bank, food pantry relationship because they're all charities. So they don't have a currency that they can use for this, and it wouldn't seem appropriate to charge them. And we coordinated this so that when I brought this topic up, we would actually allocate food to all of you in the form of cookies. So you might have an incentive to overconsume cookies, but I encourage you not to do it. So let's think about this as a mechanism design problem. Yeah, sorry, go ahead, please.
This is, or like, is there a discrete nature as well to the problem? Like,
That's a great question. So, so the question for those of you who couldn't hear was whether this is a discrete resource or whether the food is divisible. So let's talk about that. That's indeed going to be an important modeling element that I'll get to in a second. And obviously the food is divisible. How we model it to actually build a solution is something else again. So let's get there in a second. But great question. That's a reminder to the rest of you who might not be professors here that you're also allowed to ask questions. So do feel free. Is there anybody else with a question who wants to take this opportunity to ask it? You all have cookies in your mouths, but when you're ready, don't be shy.
Maybe,
yeah.
You don't want something like a script, like tokens for as a surrogate for payments.
So that's something else that would be in our design space. So script is kind of a econ jargon for kind of a fake currency that just gets used within some kind of limited domain. So that would be another kind of sensible thing that you might want to do. Script systems are tricky to run because you as the allocator of the script basically have all of the problems of a central bank, right? If you allocate too much script, then you get inflation and the script is kind of worthless and people start spending ever more of it to try to get anything. If you allocate too little script, then you have tight monetary policy and everybody hoards their script for future. And so getting this right is tricky, but that might indeed be a sensible thing to do. So right now I just want to talk about, I'm going to tell you a little bit about the actual solution, but remember my ulterior motive here is to kind of reflect on these projects from the perspective of how do we approach social impact problems. And only to a kind of lesser extent. Like this paper has theorems in it, but I'm not going to tell you even what the theorems are, let alone prove them to you. I really want to take this more as a case study. So looking at this problem from a market design lens, how would we begin to model this problem? And Siddharth is off to the races modeling the problem, but let's just sort of walk through the steps. So this sounds like a stochastic demand kind of setting, right? Agents know their probability of needing food today. So that's their private information or what we would call their type. Then this demand is realized. The center, which is the food bank, only knows the setting. So they know the type distributions, but they don't know the realization. So they don't know whether your particular food pantry actually needs food today. And the food bank, which is the center, wants the food to be used as efficiently as possible. They want the food to end up getting consumed by somebody. The food pantries are, at least to some extent, strategic. They have all things being equal, they would rather receive needed food themselves than see somebody else get it. So they don't have quite the same degree of benevolence that the food bank does. So as a researcher where some food bank representative, you have your initial meeting with them and someone says, I think I've got a market design problem. I'd love to have a meeting with you, tell you about my crazy food bank problem. I'm sort of sitting behind my desk at this point saying, yep, that looks like a market design problem. I think I want to have a second meeting with these people because this sounds like it might be going somewhere. And then, as a sort of technically minded computer science researcher who loves abstracting things, then you start concocting solutions. And Siddharth was already demonstrating what some of this concoction might look like. Here were a couple of the concoctions that drove our work. So the first thing we thought is that this sounds like a utility maximization problem rather than a welfare maximization problem. So most of the econ literature thinks about welfare maximization. What does that mean? It means trying to find allocations that make that cause the goods to go to the people who value them the most. And typically the way that happens in a market is that you make people pay you. And when you're maximizing welfare, you're not thinking about the payments. You're saying, I want the goods to end up in the right hands, neglecting the payments. But here, if you've got a script system or if you've got some other way of allocating the food, what you really care about is that the efficiency that you get kind of good allocations taking into account the payments. So you want the overall utility of the participants to be as good as possible. Now, if you're not deep into the econ world, you might think, hold on, isn't that what you just said before? Isn't that what everybody's trying to do? But actually, no, that's not what everybody's trying to do. There's actually very little research on this. It's a pretty understudied problem. And the reason it's understudied is that it's kind of hard. There aren't really nice solutions for this sort of efficiency minus payments setup. So we're we're kind of in an understudied corner of the world when this is what we care about. And that could be sort of threatening if you want an off-the-shelf solution, or that could be kind of awesome if you want to be doing new research. But anyway, that's sort of the state we're in. Please go ahead. Yeah, so my utility is going to be, so I guess this is kind of the utility statement here, that the food pantries prefer to consume the food themselves rather than to have somebody else consume it. So we're going to model them as wanting to be allocated food when they have demand. And we're going to model them as knowing, everybody as knowing the probabilities, but the food pantries as particularly wanting to, so the food bank, if you and your neighbor both have demand, the food bank doesn't care which it gives the food to, but you're going to prefer strictly that it be given to you rather than being given to your neighbor. So you could model this as kind of other regarding preferences. You could just do straight up private values. Kind of doesn't matter really in the model. That's just going to be an additive offset. And then if I'm going to have payments in the system, which kind of generically economic solutions would have payments, you're going to care about the utility that you achieve by having had something allocated to you minus the payment that you would have to make. And if I'm going to collect money from you, that's sort of in my design space, even though I said that's not a great idea. If I was going to collect money from you, then what I'm going to care about is overall the utility that I get in the system, which is going to mean the benefit that you get by having food allocated to you minus the payment that you had to make to me. And so I'm going to want to maximize that sum, that subtraction of your utility minus your payment. Does that make sense?
Bidders have a scale of valuation, or they have a distribution of the valuation?
So the bidders are going to see their realized demand. So they're going to actually get to see, in a given time period, I really do have demand today. And they're going to report that, but the center's not going to know whether they're lying, right? So it could be that you're going to say, I'm going to report demand even though it looks to me like I don't have that much demand today, because maybe people are going to show up anyway, or maybe I'd be able to use it tomorrow. So you're going to be able to misreport. Yeah.
Sir, is this real world example that has happened in past? In which area this was all happening?
Well, so this actually arose because Scott Commoners, my collaborator at Harvard Business School, actually had a food bank come to them and describe problems that they really had, and this was really something that arose for them. So we started studying this, based on conversations that he had with some food banks in the United States. So
In United States, this ideas were implemented.
So this setup really does exist in food banks in the United States. I'll talk later about whether they actually used our solution. Hint, they didn't. But the formal model came out of a real problem in the U.S. So the second thing I want to say about how we attack this problem is that the idea we had for how to incentivize agents was through auditing. So if you demand food and you don't use it, we were thinking you could be punished in some way. So you're going to get some kind of noisy sense of your demand. You're going to maybe make a report. And our thought was, if it turns out that you're asking for things that you don't need, maybe we should do something different than if you ask for something and you do need it. And this particularly makes sense because charities get audited anyway, right? Just to make sure they're not like selling it on the black market or like eating it themselves. You sort of have to have some kind of auditing oversight for charities anyway. So it occurred to us that this was kind of a feature of the market that we could use. And let me just say, as I said, this isn't a technical talk, but let me say a little bit about the kind of theoretical results that we had that kind of turned into an EC paper. So agents either need a food, so we considered, first of all, the unit demand setting, which is responding to your first question about whether we treat things as being divisible. On the next slide, I'll talk about the divisible case. But first of all, we could say agents just need a food allocation or they don't. So maybe the food bank has like more food than it would take to satisfy a single food bank. But when a food bank makes a declaration, let's consider the case where they just say kind of heads or tails. So either I need a food allocation today or I don't need a food allocation today. So then the allocation is just going to be, I'm going to choose to give you the thing you asked for or I won't. And we came up with a class of mechanisms that we called waste not, pay not mechanisms, which audit and only charge agents when they were allocated and didn't need the allocation, and otherwise don't charge them. And we proved that this set of mechanisms are without loss of generality in this unit demand setting. And we showed that, first of all, if you consider a second price auction, how many people in the room know what a second price auction is? I'm not really sure whether I'm talking to people who understand market design or not. So, okay, so it's like half of you. So for those of you who don't understand, my apologies. I'll say a few jargony things so we can move through to the second part of the talk. It's not that important for where we're going. But for those of you who do understand, a second price auction with auditing is still efficient, so it still produces the same allocation, and it achieves lower payments. And that might be surprising to you because you might know something called the revenue equivalence theorem that says you can't get the same allocation with different payments. But this auditing setting is breaks the assumptions of the revenue equivalence theorem. So we're able to get a strictly better outcome at lower price by using this power of auditing. We're able to derive this using the same mathematical tools that are used to derive the second price auction. So Meyerson's identity for payments. But our payments scale by a factor of less than 1 that has to do with the second highest type. And we can apply this to any mechanism, but this isn't going to be the optimal mechanism in this case. So we can also derive what the optimal mechanism would be, which is a kind of blend of a second price auction and lotteries. So we're able to characterize what the very best utility maximizing mechanism is in this setting. Did you have something to say? Yeah.
Second price auction is efficient in the utility sense.
No, I mean it's efficient in the welfare maximizing sense, and that's why it's not optimal. So we get the same. So second price auctions are always efficient in kind of generically without auditing, and so here when we augment them with auditing, they remain efficient. They have the same allocation they had before, but we have to pay less. The agents have to pay less, and that's a good thing in the utility setting because we don't want the agents to have to pay anything, right? The payments only exist to enforce incentives, and so that's a kind of feature, not a bug. But they're still paying us, which is kind of a bad thing from our perspective because we want to maximize utilities, and so lotteries. Where I just kind of give something at random among a set of people are better from a utility perspective in the sense that I don't have to collect money from people, but they're bad in the sense that I don't get to find out whose demand is more significant. And so by trading off those two features, I can get a mechanism that does better in the utility sense.
They continue to be incentive compatible.
It continues to be incentive compatible, yeah. I mean, in a lottery, there's nothing you can do about it, so your report doesn't really matter. In a second price auction, you have the right incentives, so you can sort of see that blending these two things would be benign from an incentive perspective. So really the question is how exactly to set up the blending. And never mind that, you can see the paper if you're interested, but it's possible to get such a result.
We didn't want to pay how we reduce the second price auction.
Pardon me?
I got confused. We didn't want agents to pay. How did we reduce?
Well, I just said it's sort of sad if agents have to pay, but then as a theorist, I just went ahead and analyzed that anyway and said, let me imagine that they're paying something, but my objective function is utility, so I don't particularly want them to have paid anything. But I do want to allocate to people who need the food. So I've got this trade-off between needing payments for an incentive reason and not particularly wanting the payments. And so the first thing I said here was that I can collect fewer payments than I would need if I use auditing. And the second thing I said is that if I use some lotteries, I can have even less payments, but I'm still collecting some payments. And the next slide, let me say something about how I can turn those payments into something that makes more sense in this setting. So the first thing I can say is, single unit demand is not actually really what we have in the world. So I might care about multi-unit demand, where people can say, I've got, I need a bit of food, I need a medium amount of food, I need a large amount of food. That changes I no longer have a single dimension mechanism design problem. And if you know about mechanism design, you know the single dimensional case we can use Meyerson, which is a powerful analytic tool. As soon as there's 2 units of something, it becomes an insane hard problem for economists. And so here we're not able to characterize the optimum, but we're able to say, the Vickrey-Clark-Groves mechanism, VCG, is kind of the only positive result for multidimensional mechanism design. And if we combine auditing with VCG, we're able to get higher utility than under VCG alone, sort of analogous to what I claimed about the second price auction. But similarly, we're not able to claim that it's optimal, and it's probably not optimal. But we're not able to say what the optimal kind of lottery scheme is here. Then, of course, we don't really want to have people pay. We'd like to use something sort of like a script system. Script itself is sort of hard to think about, although you could interpret what we're saying in terms of script. But what we wanted to think about instead, which is sort of dual to the idea of script, was the idea of punishment. So just say, if it looks like you've been asking for food that you don't need, we're going to just give you a cooling off period where you're not allowed to ask for food in the next period. So we'll have some kind of allocation mechanism that denies you the opportunity to participate in the system, or kind of turns down the volume on how much you can participate in the system if you're asking for things you don't need. And this works in a kind of repeated interaction setting. And so we also analyzed how to set up a kind of dynamic mechanism design setting where instead of payments, we instead just limit your ability to ask for things in the future. And basically the analysis, this sort of has a monetary value in the model, so we can just think of this kind of pretty directly as payments, and it works out in the same way. So let's, if you're a kind of mechanism design geek, you can read the paper and see the theorems and see all of this with a lot of notation. It basically gets to the same punchline. But from the kind of point of view of this talk, what does this mean for kind of social impact research? So we modeled some core issues that arose in an interaction between food banks and food pantries, stochastic demand, a desire to maximize utility, and this sort of unusual ability to audit consumption, but only in the case, notice that the auditing is one-sided, where we're not able to audit, if somebody doesn't report a demand, we're not able to figure out whether they were lying about that. It's sort of one-sided ability to audit when there is an allocation, whether the allocation was needed. And so we're able to put all of that together to do some kind of meaningful new theory that tells us how to improve on this objective function relative to what people knew how to do before. We were able to get a paper in a top conference, which was good for my students. But food banks aren't yet beating down our door, right? People are not coming to us saying, this solves exactly the problem we had. We want to deploy this nationwide. And there's a couple of reasons for that. I mean, they distribute more than one kind of food. Our model, even in the multi-unit case, is only talking about one thing, not about, hot dogs and hot dog buns kind of go together and I need them both or I can't give out hot dogs. That would be an example of a combinatorial preference. There can also be substitutes that say, you can give me beans or you can give me rice. They both work for hungry people. I don't care really which one you give me. I just want to have enough food to give people something. So that would be a substitute preference. And food banks might just have other considerations. They might care about fairness among the food pantries. They might care about limiting waste. They might find denying people an opportunity to participate, as good as it is for incentives, to be a problem if all of a sudden hungry people are turned away because the food bank got unlucky in an audit. And so these might be more important than incentives. And so as appealing as it was from a theoretical perspective to build this model and analyze it, it may or may not actually address the kind of underlying problem that people really have. So I think this was more of a kind of piece of theory work, and I think it shows the kind of strengths and limitations of this theoretical approach that says, we're really able to, by looking at a social problem, we're able to construct a setting that people in the theory literature hadn't thought about before. We were able to do new theory, and arguably we took a step towards being able to solve the problem, but it didn't in one shot get a solution that people could use. And you might say, it takes a long time to do economic theory work. It might just take 4 or 5 papers in a sequence before you figure out all of these different ingredients to the point where this would be really practical. But it certainly didn't get practical right away. Yeah, go ahead.
And for now, at least the food banks that you are interacting with, they just use their own sort of some tried tested methods. But are they able to articulate it as to, is there this is sort of a policy we follow, or is it more?
I mean, broadly speaking, they don't care much about incentives. And there is evidence in these markets that the incentive problems do arise. And they kind of ask people nicely to not misreport, and they see that they do misreport, and they say, gee, that's a shame. But right now they don't have what looks like an economic problem, sort of solution to the problem. They pretty much set it up as a kind of optimization problem. They think about the spoilage of food and how far it has to be transported and who's been getting what lately. And they kind of ignore incentives, and incentives clearly do present a problem in their domain, and they don't do much about that. which is why they originally talked to Scott, because they recognized this as a problem. But there's also a lot of politics within the organization. It's not clear that they were really able to make this kind of a change. That's the current state of things. It goes both ways. They get a lot. Probably the mismatch between demand and supply in an American city is probably not quite as high as in Bangalore, I would guess. They also really have problems with storage. So they get given food that will spoil. Like a baker, for example, will say, like, I made too much bread. I'm not going to be able to sell all of it. Let me give you a bunch of bread, but like by tomorrow, it's not going to be good for anything. And the food pantries can't store tons of stuff they don't need. So they really have this kind of logistics problem of like, where should we send this bread that tomorrow is going to be worthless? And sometimes they turn it away entirely because they don't know what to do with it. Transportation costs are significant. So it is sort of more complicated than just like, no matter where I send this food, somebody will eat it. Yeah, go ahead.
One solution that came to my mind is, why don't you rotate people among the food pantries? So if somebody is a good communicator, he is able to secure more food for his pantry, then he will go to some other pantry next time, maybe after 3 months or any well-defined period.
That's a great idea. That's sort of in the spirit of fairness. The solution I think that these guys are deploying right now has some of those ingredients. I guess, then again, this would sort of depend on how do you mathematically model the problem, which elements do you want to say are important. That would be a very kind of fairness-centric solution to the problem that wouldn't allow disproportionate demand to feature very strongly in the solution, right? So it might be the guy's a good communicator, or it might be that food pantry is in a particularly needy area, and it should be getting much more food than everyone else. So how you figure out which of those two cases you're in is not necessarily easy.
And one more question that.
Yeah, so are they eager to employ these solutions? That's a really hard question. Short answer, maybe no. Long answer, it's not clear that they is a well-defined concept, right? From the point of view of a researcher, I'm thinking, what does the food bank want? From the food bank's point of view, they're a large organization with offices all over the country and politics within the board. And some person thought this was a good idea, which is why they approached us. But maybe there are other people with very different priorities. And there's people who think this like neoliberal approach to technology is going to hurt the people they're trying to help. And then, there's other people who like the way things work because it currently benefits them. And so like any organization, it's not really the case that they even want one thing. And you as a researcher kind of coming into this thing have a desire to see some very clean mathematical problem and then just go to town on solving it. Certainly that's, what I'm trained to do. And that's, you end up in this sort of messy social system where there's just a lot of other stuff going on. So that's kind of a theme of where I'm trying to go, that, trying to think about how to navigate that is maybe different from what it takes to write a good econ paper. Yeah, please go ahead.
As you said, somebody approached you to look into this problem. So you don't proactively, or don't you have agents proactively looking for problems, or do you wait for people to approach?
Well, it's a bit of both, right? You sort of try to start the conversations. Here I am, in Bangalore trying to start a conversation, but it isn't like, I have a hotline that people can call. Like it's you sort of try to find, typically sort of bridgy people who kind of know. Somebody in the food pantry community who says, hey, I think I have a problem that kind of sounds to me like it, has a computational or an incentive element to it. And, a lot of these people have a meeting with you and you think like, nope, like that's absolutely not a computational problem. Like you should just do a better job of asking people what they need and like, you'll be fine. So like really doing this matchmaking is incredibly hard. Like on the one hand, it seems like, surely, every food bank in the world is not doing the optimal thing. They've got a resource allocation problem. They're probably not allocating their resources as best they can. But there's no one person to talk to. There's no one person who can put anything into practice. So setting all of these things up in a functional way is really tricky. And I think that's going to be even more true in the second example I want to talk about in a second. Yeah.
So if the supply is always less than demand is way more than supply, there's no problem, right? Like I can allot in any way and I would still satisfy everybody.
Well, that's not true. If demand is still very noisy, then even if on expectation supply is higher than demand, I might give it to the wrong people and my buns might go stale because they were really needed across town.
Maybe that's a problem specific to the North America, because here what I see is demand is way more than supply, right? So there is, in all these places there's no food wastage per se. Somebody or the other comes and eats it, right?
Yeah, I think that very likely is a problem that is different in North America. I think there tend to be a lot of the donations are especially things that spoil because those are good to donate. The person who made them, you can't save them for tomorrow, and there is demand, but it's sort of hard to forecast, and it's not always in the same place.
Sir, instead of like not involving money, sir, but I have seen in some Indian states what they do is they tell people who are coming for food to get plastic bottles, plastic waste. So people can give plastic waste to pantries for food, and food pantries can give those plastic bottles to the food bank, and some kind of supply chain may be established so that this also is the side effect of solving this problem.
Mm-hmm. I mean, that's awesome. Maybe that's an optimal solution to the problem, or maybe there are senses in which that's inefficient. Maybe it's great that people are gathering plastic bottles because you don't want them kind of clogging the side of the road, or maybe it's a waste of people's time and you'd rather they did something else. I guess this talk is sort of more about like how do we approach such problems than it is about like I think I've really cracked the food bag problem. So I guess I would invite you to think about those questions. But let me take one more question on this one. I want to move on to the other project, which I think is probably more interesting to talk about here. Yeah.
Just a small.
Yeah. So, I mean, game theory is really asking about counterfactuals. It's saying, I want a guarantee that says no matter what a participant in the mechanism does, the right thing for them is going to be to disclose honestly or to behave in a certain way so I can analyze what the welfare of the system actually is. Right? An ML approach is going to say, let me look at what people actually did and react to that. It doesn't really think about counterfactuals. It thinks about the specific things that happened in the system. And, imagine, a stock market trader who looks at whatever happened in the past and reacts always to that. I wouldn't necessarily want to give my money to that guy because the thing that happens tomorrow might not look like the past. So that's why economists do more than just machine learning. But machine learning tools can be really powerful and useful in economics. I think trying to bring these two fields together is a passion of mine. I think a really useful thing to do. But this issue of counterfactuals is usually what makes it tricky, that you want to go beyond what the data is showing you to think about things that might happen. If I change the rules, then the way people would want to respond to those new rules might be different from the way they responded before. So I can't just see it as a kind of stochastic generating process. But great question. Okay, let me go on to a second project, which I think looks more like the Indian context anyway. So I think this might be interesting for you guys to think about. So this is a project that grew out of a previous sabbatical that I took in Uganda, where we started thinking about agricultural market inefficiency. This is a collaboration with a whole bunch of people, Richard Sechabule, John Quinn, Neil Newman, Nicole Emerlika, Lauren Berkwest, Brendan Lucier, and who is that? Craig McIntosh. So let me tell you some things about Ugandan agriculture, which might in some ways be similar, in some ways be different from India. Subsistence agriculture is the main occupation in Uganda. I think Uganda's GDP is like 80-90% agriculture. And agriculture is very low tech. Most agriculture is smallhold kind of non-mechanized, and typically subsistence farmers will 1 or 2 times a year sell some surplus produce to the broader market to get money to buy things that they can't grow themselves, like salt, and to pay school fees and buy some things they need for their home. And so because they're not frequent participants in the market, they don't have good information about what's going on in the market. And they have trouble finding people to trade with. And they waste a lot of time. They have to harvest their crop at some point and like bring it to the side of the road sometimes and wait for somebody to come. And maybe they pick a bad time and their crop spoils. They waste a lot of time in doing all of this. So when Richard and John and I started studying this, we took a bunch of historical price data in Uganda and we asked whether we could find robust arbitrage opportunities. So this would be like I could, based on historical price information, buy crops at the prevailing price in city A, pay the cost of renting a truck and a driver, drive it to city B, and sell it at the prevailing prices there. And were there patterns in the data where I could consistently make a profit? That's what we called spatial arbitrage. We could also look for what we call temporal arbitrage, which would be I buy a bunch of crops in city A, I rent a warehouse at the prevailing prices, I pay for a fumigator and a security guard, and I sell it months later in city A, and can I consistently make a profit? And in both cases, we found that the answer was yes. I was actually telling somebody this at a party in Uganda, and the guy looked really horrified. He said, that's how I make my money. Don't tell anybody this. And I said, yeah, but the fact that I can find it in the data means you're not doing it well enough because you haven't arbitraged away. The market is not efficient still. So basically, if you can find arbitrage opportunities in a market, this is a sign that the market is not working properly. Because buyers and sellers are not linking up appropriately. There's an information failure in the market. The market's kind of main job is to disclose information between buyers and sellers to help them match up, and it's not working if prices don't kind of stabilize across the market. So our goal was not to build some kind of agricultural arbitrage scheme. It was to try to change a market mechanism, but being able to find the opportunity for such arbitrage showed us that the existing system wasn't working. And so our goal, and by the way, these are all pictures I took myself when I was in Uganda. These are all the actual people we met. And so our goal was to link farmers in the villages with the markets in the cities. So the markets in the cities typically had pretty sophisticated traders who really knew what they were doing and were operating at scale. And the farmers in the rural areas typically had no electricity. They were mostly illiterate. They were trading pretty rarely, but they still had cell phone service. And this was, bear in mind, like almost 10 years ago. But so at the time, there was sort of good 3G service out there, but people didn't have smartphones. They only had what they called feature phones, which meant sort of phones you could send SMSs on, but they, not like a flat panel phone. I would guess this is probably different today, but I'm actually not sure. What do you guys think? Do you think like farmers in rural areas and industry in India would have like a sort of a smartphone now? That was my sense. But so this project was addressing a time when that wasn't true, at least in Uganda. I would guess it's probably true even in Uganda now. So our solution was to build sort of a combination of like the Chicago Mercantile Exchange and Craigslist running over SMS in Uganda. And so we built a system where you could use SMS or something called USSD, which I don't know if you guys know what this is, but it's sort of like an SMS interface that has a kind of session key, so you can send messages back and forth, but it's still over text. And so you can make a bid that considers price, quantity, and geographical location, and then we would construct a matching, and we would send back an SMS saying, we found you somebody to trade with, in this place. And we actually deployed this thing in Uganda. We had these like outreach workers. So this was like a training worker out in a village in Uganda. I took a picture of his shirt, and his shirt has like instructions on it for people about how to use Kudu. And so when we started this off, we built this automated matching system, which kind of does what an economist would think made sense. We would find a maximum weighted bipartite matching in the kind of in the graph, under the constraints people had about where they were located and how far they were willing to travel. And we did this by first pricing buyers and second pricing buyers and first pricing farmers. So basically, we gave the sort of pricing power to buyers because the farmers were the most desperate to trade, and we just wanted them to. They were just happy if they got matched. And we ran a limited trial where we. Turns out in Uganda, you can pay people to run radio ads, and a radio ad is not like 30 minutes. It's not like 30 seconds. It's like 30 minutes. It's like somebody just talks on the radio who like doesn't know anything about your thing, but you give them a little some facts, and they just like ad lib about it for 30 minutes on the radio. And for some reason, people listen to these shows on the radio. and actually do participate. So we got a student at Macquarie University to help to respond to malformed SMS messages, of which we had many. We sort of woke up really early in the morning and went to some of the vegetable markets in Kampala and did some outreach to buyers and said, would you be willing to buy some stuff? And we found some people who'd be willing to participate. And we managed to enroll kind of hundreds of users and run a little trial. And then we ran out of money and we stopped the thing. And we wrote a paper about our experience. So the question is whether, we found these sort of arbitrage opportunities in the data, like, what reason did we have to trust the data? Good question. Like everything about this project, like I'm just showing up in Uganda and knowing, not very much. So my Ugandan collaborators thought this was sort of decent data. Indeed, you might want, it's based on market surveys. It's based on, researchers who went out and tried to understand the agricultural market, not for this purpose, but just kind of anyway. And, I guess our belief was if the arbitrage opportunities were kind of big and free and very consistent, this was sort of a bad sign. It didn't necessarily mean that exactly these strategies would work, but if the market was efficient, you generally think this wouldn't show up in the data. So we saw it as a kind of red flag that the market was probably failing, maybe not in exactly that way. And certainly the kind of qualitative information we had by going around and talking to people about their experiences in the market were similar. That people felt that, indeed the farmers just had no idea what was going on. The farmers we talked to certainly said they had no idea. Yeah.
Once the buyer and the farmers are matched, your intervention ends at that point.
That's going to change on the next slide, but at this point we would just send people an SMS and say, like, God bless you, go out there, like, go track down Richard. He's in this parish. He claims to have a whole bunch of matoke that he wants to sell at this price. Like, good luck to you. See what happens to you. And that was it for us. You probably have some ideas in your head about various ways that would be limited as an approach. I agree with you, but that's what we did.
Transportation problem you were not solving. You were just matching buyers and sellers.
Well, so the buyers, so the reason we set up the market, we thought about a whole lot of different approaches. And what we eventually came to understand, there are a bunch of things we were naive about, and I think there's some things we got right. I think one thing that we got right was understanding that the farmers and the middlemen were really the market that was failing. And the middlemen, buy up a bunch of stuff and then sell it to the actual people who want to eat the food. That market seems to work pretty well. So we didn't intervene at all. So the buyers we're talking about here are really like wholesalers, and they typically have transportation. So these are somebody with a 13-ton truck who like drives around to rural areas and buys stuff. But when we spoke to the wholesalers, they said, like, I always go back to the same farmers. I have relationships with certain farmers, and it's just hard to find out. These guys only show up occasionally. It's hard to find out who's going to have crops at a particular time. And sometimes there's sort of too many farmers when there's a really good crop. Sometimes I can't find anybody, and either way, I don't really have a way of finding new people. And so that was the problem we tried to solve.
So if Sam is matched to IO, then Sam and IO, you used to give phone number of IO to Sam and Sam to IO, and you used to tell them that you have been matched at $2, and then it is kind of understood that Sam will send his vehicle and take the crops.
That's right. But let me go on, because some of these questions get made more interesting in the next step. So in 2015, some development economists from UC San Diego and UC Berkeley found out about our initial work and said that they were interested in trying to build something on top of this at a larger scale. And so they had some enormous American grant that they wanted to, but they didn't have anything to sort of run a market. So they wanted to kind of take our technology and like do a big study on top of it. And so they ended up, building this office in Kampala full of a bunch of outreach workers who would actually phone people up. I guess these are the outreach workers, and this is the kind of team that managed them. And also this company called Agronet, which, like, all of these people got dispatched out into different parts of Uganda to work in different villages and like build little teams of people that would recruit buyers and kind of build some local infrastructure to do all of this on a bigger scale. And so over this period of time, we we sort of ran this thing again. We sort of started the project in 2015, and we ran the thing again, and we ended up enrolling tens of thousands of users in the system. This was not as a CDF. This was our initial pilot, and then when we started the reboot, the thing got a whole lot bigger. And you can see both that we were enrolling a lot of new users and that existing users were coming back. So we did this thing at a much bigger scale. We were also, because we had all this grant funding and these teams of workers, we were able to call people back and actually find out whether they did the trade. Because otherwise, our initial thing, we didn't have the manpower to actually find that kind of thing out. And indeed, many people did actually consummate trades based on our matches. So we ended up doing millions of dollars of trade, mostly in maize, but then kind of in a long tail of other agricultural commodities in Uganda as well. We probably supported 20 or 30 different agricultural commodities, and these were the most popular ones. So probably lots of other trade happened on our market that we don't know about. These were only the trades that we were able to track somebody down and verify. And again, based only on verified data, these are the places where the trades happened. So most of the trade doesn't show up here because the buyer and the seller are very close together, and so their lines kind of don't look like anything on this graph. But we also had a lot of long distance trading happening where people were willing to drive some people would tell us, like, I'm willing to go anywhere if you find me a good deal. And indeed, there really was opportunity for this kind of spatial arbitrage. So sometimes we would match people really all over the country. And rural Uganda is probably worse than rural India from the perspective of the roads just being really hit or miss. So these were really adventurous people who were willing to take these long trips. But this didn't work the way that we would have liked it to work. Here's what happened. These deal coordinators, the people in those sort of phone booth pictures that I showed you, were shown this interface in our system of different people, what district they were in, what county and parish they were in, what they were asking in terms of quantity and price, how many times we'd ever matched them before, and on both the ask side and the bid side. And then they would manually go through and try to find matches, and they would phone people up and say, well, here's what I've got for you. Would you be interested? Do you still have your produce? And they would just go through this whole thing, just phoning people all day, which made us very sad because this was the thing we were trying to automate, but we couldn't get them to do anything automated. So we ended up building them what they really wanted. So they would record whatever information they had. They'd follow up. They'd make comments and ultimately kind of track all of this stuff in our system.
Sir?
Yeah.
Sir, your revenue chart looked like exponential growth. What happened after 2018?
It's coming in the slides, but basically we ran out of money and we had to shut the thing down.
Sir, why you should have charged commission from people so that you also make money and you are able to keep helping them?
Definitely possible. I'll talk about that at the end. But that's obviously something we did think about. So what were some challenges? Usability was really tricky. So we had to support many different local languages. And so our app had to run. I guess we ran the app in 4 different languages. And there were many other languages that people sometimes had to be contacted in. We had to go into villages and run these trainings. So here you see like an actual training of a bunch of farmers where the guy's t-shirt is being pointed to by the training guy, talking through how to use the IISc interface. The farmers were really interesting. Like getting a whole bunch of people to show up to actually learn about this thing was not hard. The farmers definitely saw this as a need, but getting to the point where they understood how to use the system and were convinced that it wasn't a scam was less direct. And we learned when we interviewed farmers that most trades didn't consummate. So when we found a trade that looked profitable on paper, fewer than 10% of the trades that we proposed would actually happen. Partly this was because of modeling issues. So we tried, but it was really hard for us to model transportation costs because we just didn't have good data on road quality, on the routes that people would actually be able to take. And reliability of both buyers and sellers was a big issue. So we heard stories about somebody would drive a long distance, and then somebody would be unwilling to honor the deal that they had made. Somebody would drive a long distance and then would themselves offer a very different price than they'd offered before. So we had sort of cagey behavior on both sides. We thought about some kind of escrow system, but there wasn't a sort of inexpensive way of doing this that wouldn't have added really high transaction fees on top of everything else. Timing was hard. Typically, the farmers were really, really liquidity constrained. So when they were selling, they needed the money very quickly. And if they found another deal, they would just use it almost right away. And then somebody would be coming and the trade would be gone. And it was really hard for us to repair solutions. So a buyer would often want to fill up a 13-ton truck with more than one farmer's stuff. So we'd sort of assemble a route for them, and then trades would start falling apart and they couldn't fill their whole truck and they would go somewhere else. So finding something that we had the right kind of information to model was really tricky for us. And I guess more modeling issues than that even, but it was really tricky. So our most recent pilot, that when we stopped it, the problem was that it was really labor intensive. We provided in-village support services. We did this verification. We ran a call center and staffed it, every single day. And we indeed, imagined that maybe we could take a portion of every trade and make the thing profitable. But it was hard because we didn't have somebody at the point of sale, right? So we didn't have a way of knowing whether the trade actually went through. If maybe the right way to run a system like this would be where the money would change hands through phones, and so we could take a cut there, but we would still need a way of knowing what the transaction price actually happened at and whether the trade really happened. People could lie to us about these things because it isn't happening in a centralized way. So we never really found a way around that problem. We were really interested just in kind of running this as a kind of charitable endeavor. Frankly, we don't think it was that expensive to run relative to the good that it did. So actually, I don't know if I feel like I might not have this on the slides. I'm not sure why, but actually maybe it'll be on a subsequent slide. But the development economist that we worked with did an analysis and ended up arguing that we did tens of millions of dollars of economic benefit to the people who participated in our study, which was pretty amazing to us. And actually happened in a very unexpected way. So their analysis said that we hurt traders, as you would imagine, because they ripped off the farmers less. And we helped farmers, but there's so many farmers in Uganda that the amount of help was more than the amount of hurt, and we created a lot of benefit. And actually the main form of benefit that they calculated that we did was not so much in the trading platform, but it was actually that the trades that we observed allowed us to make a price advisory system where we would broadcast the prevailing prices that we observed. And this allowed other farmers off platform to get a better deal for their crops, because the farmers just had no unbiased source of information about what prevailing prices were. The people that they talked to had incentives to misreport prevailing prices to them. And that really this price advice, we had many tens of thousands of people subscribed to our price advisory services. And it looks like that was really the biggest benefit that we had. Although we wouldn't have been able to do this if we didn't have some trading happening that sort of drove that. But it looks like that was the really big gain. So, from my perspective, if you're a government aid agency wanting to help, impoverished farmers in Uganda, a little bit of a subsidy to run this kind of an operation might be well worth it for the benefit that came. So it's not clear to me that a kind of commission structure would be required, although it definitely is true that if you can make a self-sustaining business, you're much more likely to have something that can succeed.
It's also informative about the kind of crop you should grow.
That's a good point. I don't know whether we studied this over a long enough period to know whether that sort of planning benefit was helpful to people, but it might have been. Something we certainly observed about the Ugandan agricultural market was that it was just very bursty. So they would have good rains and then everything would be flooded. They would have like a war in the north and then things would be really disrupted. So almost every season, something very different would happen. So it's not clear the extent to which long-range planning was that possible for people, but maybe so.
But you also like maybe slight digression, but so in India there are particular crops that really are like price fluctuations is sort of the biggest indicator of market inefficiencies. Like onions can like suddenly shoot up to like 10x their standard price in a very short window. Was similar patterns.
We saw similar patterns, although I think they're both. I think it's evidence both of market inefficiency, but also of just kind of precarity, right? Like you don't have crop insurance, you don't have good use of fertilizer, you don't have various kind of best practices in irrigation and so on. So I think that also produces really high variance, which isn't really a market inefficiency problem. It's more of a kind of agriculture technology kind of problem. Anyway, so we got interested in what it would look like to run Kudu in a much leaner kind of way that wouldn't require so much kind of centralized funding. And our idea was to replace the deal coordinators with a sort of smartphone application on the buyer side. So we thought, even if the farmers aren't very sophisticated, even if maybe the farmers now even would start to have smartphones, but the farmers were mostly illiterate. So even if they had smartphones, we weren't sure that they would be able to do really sophisticated searching. But we had this whole interface that we built for the deal coordinators to try to help them find good matches more quickly and to phone people up. And so we thought, what if we took that application and we kind of pushed it onto the buyer side, and we made a sort of Google Maps, Yelp kind of interface where you could just sort of search for what's available in a geographic area and ultimately phone people and then just negotiate with them. And then the buyers could do all kinds of complicated filtering about what they were looking for. And we could accept asks from sellers via SMS, unstructured SMS or WhatsApp, and maybe a small call center. Maybe we could pay one person to kind of just take stuff that wasn't working and kind of put it into the system. So we ended up, my grad student ended up building such an application just on a kind of Google Play platform that does all of this. So you can go in and select something you want to buy and sell. You can filter on price and quantity and recency. You can eventually kind of zoom in and out on an area and find pins that correspond to individual people who've made asks in the system and then ultimately phone them. So this whole thing got built, but actually never got deployed. So we just released it open source on the internet in the hopes that other people would pick it up, and it's kind of out there. And we've had a few nibbles, but I don't think it's ever been deployed at scale. So again, let me kind of step back and think about what does this mean from a AI for social impact kind of perspective. I think I'm convinced that the problem of agricultural markets in Uganda and other kind of places at similar levels of development is a compelling one to study. I think there's a great deal of market inefficiency that better information structure would help to address. And I think some kind of electronic market that connects farmers and traders is a valuable thing. I think matching is useful. Price advisory is probably even better than matching, but I think there's a synergy between offering both. We had a really long and twisting road to our current point where we had reasonable traction, but we never got the kind of explosive self-sustaining growth that we were hoping for. We faced real technical challenges, but unlike the first project, we didn't ever do really significant theory. We ended up doing a lot more kind of user studying and kind of system building, but not like economic theory. And some of the most appealing sort of economic things that we tried just absolutely didn't work, including a lot of stuff I didn't tell you about. We thought about like how to build reputation in the system. We thought about escrow. We thought about how to rank quality. And all of these things just really didn't work out in the Ugandan context. And I guess in the end, I'm convinced there's a lot of work still to be done. I think that the design we have, I hope, could still be useful as a starting point for others. And I think many people have kind of talked to us over the last couple of years about this system. So I think there's really a need for something like this, although maybe it needs to be driven by a big industry partner to really achieve the scale that it needs. So let me end by just giving a couple of reflections on what can we learn from these tale of two projects, from these two different vignettes, and what this means for doing kind of socially impactful research. So overall, it seems to me that AI technologies that get used in the real world are really hard to develop. solving even really straightforwardly stated problems is often pretty difficult to do. Indeed, it's often computationally intractable or even provably impossible to do properly. So we as engineers are trained to do lots of really clever work to come up with approximate solutions, to reformulate the problem or relax it to something we can solve, to come up with heuristics that allow us to attack the problem in a limited domain. And we have a literature that focuses on taking these clever ideas that we've come up with and communicating them to each other. So our viewpoint is really about taking some problem, abstracting it in a clever way, and showing how we're able to get traction on it. And I think when we look at this AI for social impact research community, we're finding out what happens when researchers with this kind of training get pointed at social problems. And I think there's sort of a couple of different modalities that emerge. The first is what I might call the sort of write a paper modality, where the researchers are thinking especially about their academic incentives. And the first project that I described might be an example of this kind of modality. So you get approached by a stakeholder who has some good idea for how your research expertise aligns with the social problem. And when you're sort of screening it, you think about it and say, yeah, I think there really is something there. It does sound to me like something legitimately present in your problem, aligns with my expertise as a researcher, and I think there's something we could do. And so you begin by abstracting some kind of clean statement of the problem. You try to solve it, maybe iterating on the problem definition. Maybe you start with the unit demand case, and then you think about the multiple demand case, and then you add script and so on. And at some point you get a positive result, and then you're like, cool, now I know we have a paper for sure. I've got a theorem, let's see how many elaborations we can get in by the paper deadline. And you kind of keep iterating. At some point you hit the paper deadline, and then you move on, right? Then you no longer have money to pay people because the people you're paying are paper writing people, and they've written their paper, and you put your thing out in the world and you hope somebody finds it, and you change gears and work on the next project. And I think that's a pretty fair description of what we did in the food pantry problem. And who knows, maybe 10 years from now, I'm going to find out that this was the kernel of an idea that led to something really productive out in the world. But so far, it doesn't seem like it, at least for that project. But there certainly are examples where this sort of approach has worked well. The second kind of approach, I think, maybe looks a little bit more like Kudu. And this is the sort of be an entrepreneur approach. And here you can sort of look at the way people think about startups. And you can think of what people in the business literature call the lean startup recipe, where you begin by trying to understand the market as well as you can. You build a prototype as quickly as you can. You get lots of feedback from people on the prototype. You build kind of a crappy prototype that doesn't really work, but you talk to your user base, you find out how they feel about it. You pivot if you need to do something else, and you kind of keep iterating on this thing, building quickly, getting feedback, and you see if you can achieve scale before you run out of money. And it's worth noting that 90% of tech startups fail, even outside the social impact space, right? Even if you're in the space where making money is not hard, most startups that seem like they have a good idea don't really succeed from a business perspective. So if you're going to try to do the same thing to solve a social problem in a place where the opportunities to make money are kind of by definition less, you clearly don't have an easier problem than if you're trying to build a consumer-facing application in a place where making money is your goal. And so it's tricky. If you lock into a solution right at the beginning, I think it's less likely that you'll be impactful in practice. And if you just focus on trying to do something that's going to move the needle in practice, then it's really hard to leverage your core expertise as a researcher. You end up applying kind of off-the-shelf machine learning and building systems and thinking less about what it takes to actually leverage your own core expertise. And of course, what we would like is sort of model number 3, like both of these things at the same time. So sort of the unsatisfying approach is you do sort of number 1 and number 2 in parallel. You try to attack some real problem and iterate and build relationships with the local community, and periodically find sort of abstractions that might not really be the thing you're doing, but sort of throw off papers along the way to keep your graduate students employed. And some people do this. I think it's a bit unsatisfying because there isn't much of a causal connection between the papers that are getting written and the thing that actually gets deployed. And then once in a while, some of our field's most celebrated projects really do number one and number two in parallel with kind of meaningful connections between the theory and the impact. I think many of you probably know Leyton-Brown, who's probably the most sort of visible hero at being able to repeatedly do this. Although even for his work, I think if you look at it from a critical perspective, the sense in which the mathematical problem that got attacked in the paper was really necessary for the social impact that got deployed is not always, equal, right? Sometimes it's really necessary. Sometimes it's kind of gravy on top. What are you going to do, right? That's not a criticism, but just kind of an observation that, doing hard scientific work is not always what's necessary. But it's sort of hard, you go beyond Leyton-Brown to say, who are the next 5 best people around the world at doing this? It falls off pretty fast. So we really haven't found a good recipe for doing this. And the key question I think that, a researcher, wanting to think about this space would have is, is there some kind of secret sauce? Is there some sort of Leyton-Brown approach that we should all be following? Or, is there just kind of, either luckiness or some kind of genius in sort of shepherding relationships with stakeholders that's hard to replicate? Here are my thoughts on what such a secret sauce might, some elements of that secret sauce might be. I think novelty in problem formulation is at least as important as novelty in technical solution. And I think this is tricky because our field really tends to think that the technical solution is the place where you have to innovate. Whereas really thinking about how am I going to set up the problem? How am I going to think about different ways that I could abstract the problem and pick the one that's going to get the most traction on my domain? I think that's the place where we really need to work well. And actually, that's why Melinda and I set up this AI for Social Impact research track at AAAI maybe 5+ years ago, because we wanted to have a place where researchers could not have their papers rejected if they didn't have a new method, where instead they could describe their core contribution as having been in formulation. But I think that's still something people really struggle with. They still feel like they have to propose a new algorithm if they're doing new work. I think the ability to communicate with and really understand the needs of stakeholders is really key. And that's something we're not trained well in. So I think that's something but it really seems clear to me that the people who succeed in this space are people who learn how to really develop meaningful connections with stakeholders. And maybe to say that in another way, finding somebody on the stakeholder side who really speaks our language and is interested in, being a broker, into the rest of their organization to try to explain this technical solution is absolutely critical to making something like this work. My project in radio spectrum allocation in the US government was absolutely critically successful because of one guy who just believed in the ability of markets to make this work, who worked for the Federal Communications Regulation body in the United States. And he was just kind of the inside guy who kind of advocated tirelessly for auctions. Government procurement auctions in health, in the military, other parts of the United States would make just as much sense, but they've never taken off. And I think it's largely because they just didn't have that kind of internal champion. So I think identifying these people that one can work with is just absolutely important. And it's even better if this person not only knows how to kind of advocate on the inside, but they understand your discipline well enough that they can start to propose things to you that might look like the kind of thing you know how to do. And you're really lucky if you can find such a person who can help you figure out together problems that are both practical and also technical. Because in the end, what we really understand is the technical stuff. So here's my last slide. Something that I've lately been giving a lot of thought to is how can we teach computer science students to do better research in this space? And I've become really interested in the way that we teach business school students. I think we should really think about the AI for social impact space as looking more like entrepreneurship than it does like writing a theory paper. And I think that means we should look to some of the kind of teaching approaches that have proven themselves in the business literature. One approach is using cases, so writing up little ingredients of problems that have been faced by people in business situations so that you don't have to learn by failing. You can learn by studying the failures of others. And that's sort of partly the sense in which I offer this talk, as really not trying to offer a rosy view of my own past projects, but really trying to think both about the ways in which they were successful and the ways in which they failed, because I think we need more conversations like this if we're going to develop some of those best practices as a community. I think we need experiential learning opportunities for students that really give them the opportunity to actually engage with some stakeholders and try things out. And we need, if we think that problem reformulation is the really critical piece, we need to give students training that allows them to formulate problems multiple times, rather than this kind of assignment modality we have where the formulation is given to you and you just kind of run off and solve it, and you never really think about how to reformulate something. And ultimately, I think we need to try to find partners to work with at least as much as projects. So I think developing relationships with individual people is really critical. We need to reward in junior researchers, in colleagues when we review papers, innovation in the business model or the application strategy at least as much as in the methodology. And we need to share best practices regarding the processes that we used as much as we do in the outcomes. And ultimately, I guess none of this is really a surprise. We always get better at what we focus explicitly on. So if we really reward people only for algorithms, we're going to get lots of algorithms, but we're not necessarily going to get tangible deployed solutions. So this is my conclusion slide. So in the end, I think AI researchers can impact society by trying to write a paper. And I gave you an example of an attempt that I did to write a paper for food banks that did some nice theory and might someday move the needle for food banks. They could try to be an entrepreneur. That can make it hard to write a paper. Although I will say, I'm surprised in this second project, we really didn't try very hard to ever publish anything. We really just tried to do something that would make a difference. I've been really surprised by how much the CS community has wanted to hear about this project, even though there's really no algorithmic contribution, even though everything we did was pretty off the shelf. I would say if you're a young person who wants to do something in a kind of applied space, it's initially hard to get off the ground, but the number of people who will be interested in what you did is more than you would think. So I think that's been a really positive experience for me. And then, of course, there's this sort of project model 1+2 have it all, which I think sometimes fails. There's occasional examples that it seems sort of tantalizingly possible. And I think we all as a field have to figure out what's the difference between these two cases so we can get better at it. And overall, I think we really have a moral obligation as people at this cutting edge of AI and computer science technology, where it's just so obvious, I think, to all of us that the new technologies and novel ideas that we have really have the capacity to transform people's lives. And so I hope that we as a field can get better at this so that we can have a real impact on the world. Thanks for paying attention to all this.
Yeah, Kevin, this is for you.
Thank you.